Class 2 levers. Levers can be arranged in different ways to do different kinds of work. A Class 2 lever has its fulcrum at one end of a lever arm. The load is between the fulcrum and the effort. With this kind of lever, the direction of effort is not changed. Pushing up on the Class 2 lever arm pushes up on the load. Pushing down on the lever arm pushes down on the load. To gain a mechanical advantage, the load is placed closer to the fulcrum than to the effort. The Class 2 lever always reduces effort. A wheelbarrow is a Class 2 lever. The wheel is the fulcrum and the effort is applied to the handles. The load sits close to the fulcrum. With a wheelbarrow, it takes less effort to lift a heavy load, but the cost is distance. Effort is exerted over a greater distance than the distance the load is lifted. A paper cutter is another Class 2 lever. In this case, the lever arm is a blade and the paper's resistance to being cut is the load. The paper is placed between the fulcrum and the effort. Effort applied to the handle puts pressure on the paper. A door is also a Class 2 lever. The fulcrum is the place where the door is jointed to the door frame, and the effort is applied to the doorknob. What would happen if the doorknob was placed in the center of the door instead of at the outside edge? Would the door be easier or more difficult to open? What would happen if the doorknob was moved even closer to the fulcrum? Paper cutter is a Class 2 lever. A door is also a Class 2 lever. Class 2 levers can work together. The place where the levers join is the fulcrum, and the effort is applied to the opposite ends of the levers. The load is placed in between the fulcrum and the effort. The garlic press and the nutcracker are double Class 2 levers. Should the nut be placed closer to or further away from the fulcrum to gain the greatest mechanical advantage? A bottle opener is a Class 2 lever. The resistance to the bottle cap is the load. A nutcracker and a garlic press are examples of double Class 2 levers. The bellows. In early times, tools and weapons were made by blacksmiths. A blacksmith shaped metal after heating it to a high temperature in a forge or furnace. The blacksmith used a bellows to force air into the forge. That made the fire burn hotter. A bellows is a double Class 2 lever. Each lever is a board, and the boards are held together by a hinge that acts as a fulcrum. The boards are surrounded by a pleated bag. There is a nozzle at the fulcrum end of the bag. Air is the load, and the effort is applied to the handles. When the levers are separated, air enters the bag through a valve in one of the boards. When the levers are brought together, the air streams out through the nozzle. Class 3 levers. A Class 3 lever is another arrangement of the lever. In a Class 3 lever, the fulcrum is at one end, and the effort is applied between the fulcrum and the load. With this kind of lever, the direction of effort is not changed. The load moves in the same direction as the effort. The gain offered by a Class 3 lever is one of distance. A fishing pole is a Class 3 lever. The hand placed at the end of the fishing pole acts as the fulcrum, and the load is the fish that's caught at the opposite end. The hand between the fulcrum and the fish applies the effort. The hand applying effort moves a short distance to move the fish a longer distance. The cost is effort. A hammer used to drive a nail is another Class 3 lever. When you hold the hammer's handle, your elbow acts as the fulcrum. The load is the resistance offered by the material into which you are driving the nail. The hitting end of the hammer moves farther than your lower arm does to apply force. The hitting end gains not only distance, but speed to do its job. Many sports are played with Class 3 levers. Baseball bats, hockey sticks, golf clubs, and tennis and badminton rackets all gain speed because the hitting end moves faster than your arm. Class 3 levers also include many tools. Shovels, pitchforks, hoes, and brooms are all Class 3 levers. They provide a gain in distance. Your arms and legs also work as Class 3 levers. Where are the fulcrum and load for these Class 3 levers? Can you determine where the effort is applied? Class 3 levers can work together. The place where the levers join is the fulcrum, and the effort is applied between the fulcrum and the load. Tweezers and ice tongs are examples of double Class 3 levers. The arms of tweezers work together to form a double Class 3 lever. Ice tongs are an example of a double Class 3 lever. Catapults. In ancient times and in the Middle Ages, people used war machines called catapults. Some of them worked as Class 2 and Class 3 levers to shoot arrows or hurl heavy rocks. One end of the lever acted as the fulcrum. A rock load was placed at the opposite end of the lever. Beyond the load, a rope attached to a windlass wheel and axle pulled back the lever. This is a Class 2 lever. When the rope was released, the lever propelled the load a long distance with great force. Can you see how the lever throwing the rock is a Class 3 lever? Where are the load, the effort, and the fulcrum?